Yeah, all good?
Yep.
Excellent. All right, so the quotient rule. Quotients just mean division. That's all it is. So if we were given a function, y equals a function of x divided by another function of x, if we're given that, then to find the derivative, this is the formal definition of what we're looking for, but we're not going to use the formal definition all the time. We're going to use the abbreviated formula. So the abbreviated formula for finding the derivative of this function, which has one function of x divided by another function of x, goes like this. The derivative, that's close.
Straight out the outtakes reel.
The derivative, but oh, that was a little bit juicy.
I did that in
Too
bio
much.
before.
Okay, thank you, Greg.
It wasn't me. It was her.
All right, the derivative of y will be v u dash minus u v dash all over v squared. All right, so that's now how we're going to remember this whole process for finding the derivative of a function where it looks like we've got one function of x divided by another function of x. Now, oddly enough, that you don't always have to do that. You don't always have to. In fact, some of you yesterday already were dealing with one function of x divided by another function of x. And do you remember what you did in order to deal with that?
You changed it into...
Change the denominator to have
that.
a negative power, didn't you? And then you did the derivative. It doesn't matter whether you use that, the product rule, and do that little technique, or use the quotient rule. It works either way. You'll get exactly the same answer, which you would hope you would always get the same answer. So let's go straight into doing an example from exercise 8.10.
I've got much homework.
All right, and prompts. We should do question 1, but I want to tackle something that's a little bit juicier than just 1A. So could someone pick a letter somewhere beyond
Juicy.
H?
C.
J. Juicy.
H-I-M.
M. M looks good. Let's go with M. Okay, so M.
That's annoying. No, M.
Okay. There, we've got M. That's something that's a little more challenging than just the earlier ones. The earlier ones are exactly the same process, but this one just looks a little more
Is the
challenging.
top U and the bottom V?
Exactly. The top will label as U, and the bottom will label as V.
Why?
No, Y's out the front. Because what we're saying, I know what you're saying.
Because given
Okay, because see over here, if we're given y, which is a function of x divided by a function of x, this function here, u, is a function of x, and this function here, v, is a function of x. If it looks like that, then we just label the top bit u and the bottom bit v.
Can you label the bottom bit U and the top
We
bit
could, yes. The convention is normally to do it this way, but it really,
If you do it the other way around, does that mean you have to change your formula?
they have to change around too, yeah, that's right. And this wouldn't be v squared on the bottom, that would have to be u squared.
does that mean?
So it's best just to stick with like the process, the format that we're doing. We'll call that u and v, yes.
No, I'll just wait for you to explain it.
So what's u equal to?
X squared plus 4.
X squared plus 4. And what's v? Oh, what's u dash equal to?
2x.
2x.
And then
2x.
is
And what's
v
equal to?
Is that 1 over or not?
No.
So
V is just actually equal to x squared minus 5. Okay?
Okay.
It's just x squared minus 5. You okay with that, Tom?
Yeah.
Yeah? So, Jen, what would v dash be equal to?
No.
If we find the derivative of that?
VU dash B.
Just take that power down the front. It's going to be 2x. Okay?
Minus U.
And what would v squared, because we actually need a v squared element in our expression, what would v squared be equal to?
X squared minus 5 squared.
Exactly. We're going to have that element in our expression. And now what we do is we take all these little bits that we've created and set them up so it looks like that. So the derivative, y dash, is equal to v, which is x squared minus 5, times u dash, which is 2x, minus u, which is x squared plus 4,
times 2x
times v dash, which is 2x,
over.
all over x squared minus 5 all squared.
Expand.
I don't know that I'd expand, but gee, I wonder if that helps
Can you
us.
cross?
It does.
Maybe, mate, let's
Can you
expand
cancel
it.
It does help us.
Let's expand it, yeah.
Okay, yeah.
I was going to take 2x out as a common factor.
Can't you get rid of the x squared minus
I guess there's
5?
different things that I could
Wait,
do. See how
just
2x
do it.
is here,
Just do it.
and there's 2x there. So I'm going to take 2x out as a common factor, which would leave us with x squared minus 5 minus x squared plus 4 all over x squared minus 5 all squared.
Can you minus the x squared minus 5 at the top?
Yes, well now what I'm going to do is remove these brackets from inside the square brackets. So we'll have 2x outside of x squared minus 5 minus x squared minus 4
Oh,
all over
I think you got different.
x squared minus 5 all squared.
I got it right.
Yeah.
I got it right. You got it
Same.
wrong.
But I think
So do you see
I expanded.
with this,
Same.
yeah, you see with this x squared cancels out with that x squared. So inside the brackets, what value do we have inside the brackets?
Negative 9.
-9, that's right. So that'll be 2x times -9. What's 2x times -9?
Negative 18x.
Negative 18x. So we're going to have minus 18x all over x squared minus 5 all squared. And after that, I
Is that
don't
right?
think
Yeah.
we're going to get anything new.
What way do you recommend that way?
Oh, look, it doesn't matter because we'll get exactly the same answer. So I
Try
think what
another.
you're saying is you expanded from here, didn't
yeah,
you?
and I just
So
got,
you had
I had 2x to the power of
2x cubed minus
10x
10x
minus 2x cubed
minus
8x.
2x cubed minus 8x
And then over,
all over,
and then you just
This
cross
bit?
off.
and this cancels with that.
So it's just,
So then we still end up with minus 18x over. So that does turn out to be
and it was
considerably
easier.
quicker, doesn't it?
Yeah.
Okay, it may be that it's quicker and sometimes it may be not so. But
How many,
in
do you,
that case, it turns out to be considerably quicker.
how many would you like us to do from question 1?
Look, I want you to do, we've done M. There's no need to go back and do simpler ones, I do believe. I reckon you can go on, actually, do A, because you'll get an interesting thing happening with when you find the derivative of U. So I would have a crack at A and maybe C, but then after that, you just pick and choose. Do enough of them so that you're comfortable.
Just one.
All good? All good? Yeah.
How'd you get the v squared?
Oh, look, the reason why the v squared is there,
Yeah.
you would need to look at the proof that justifies this formula existing. Okay, now the proof for why that formula exists is just immediately given to you underneath the title in your textbook for the quotient rule. But in the end, v squared is just an essential part of the whole process. what I'd like to do also is just show that we could have done this by using the product rule. I could have written this as x squared plus 4 times x squared minus 5 to the power of minus 1. You okay with that? And then in this case, the product rule, this is u and that's v. So we'd say u is equal to x squared plus 4, u dash is equal to 2x, v is equal to x squared minus 5 to the power of minus 1, and v dash is equal to minus 1 times 2x times x squared minus 5 to the power of minus 2. And u dash would have equaled, what would u dash equal? vu dash plus uv dash. What's v? Yeah, x squared minus 5 to the power of minus 1. What's u dash? Times 2x plus, what's u? X squared plus 4. And v dash? Minus 2x times x squared minus 5 to the power of minus 2. Now what that really looks like is 2x over x squared minus 5 plus, well, not plus, because that's going to be a negative, isn't it? That's a positive, that's a negative, so that will actually be a minus 2x outside of x squared plus 4 all over x squared minus 5 squared. And what do you have to do when you've got, when you want to add fractions? You've got to have a common denominator. So the common denominator I would be getting is this one here, which would be x squared minus 5 all squared. So now it's starting to look like that already, isn't it? And that means I'm going to multiply this by one of those. Okay, so that 2x will have to be multiplied by x squared minus 5 minus 2x outside of x squared plus 4. And at this stage, that's where you might expand.
Is it it's minus?
So we'll have 2x cubed minus 10x minus 2x cubed minus 8x all over this, which that cancels with that. So we'll have minus 18x all over x squared minus 5. So isn't it satisfying that here we've used the quotient rule to get that answer, here we've used the product rule and we get exactly the same answer, it's just a different method of approach.
So you can do the same either one?
Yeah, you could use either one, whichever one you feel most comfortable with. Sometimes you'll find that the quotient rule is more helpful, sometimes, but they will both work all the time.
Okay, yeah.
You guys good to go?
Did we stop playing it?
Sorry?
Do you mean?
Oh,